back into Mastercam here. So what I forgot to do on this previous contour toolpath is add my name here to what I'm doing. So we want to make sure to comment on our toolpaths. Profile, the outside. I also got my mouse clicks to show up here, which is nice. Alright, so we'll go ahead and OK that. Now, let's say I wanted to come in here and create another finishing pass. All I have to do is select each toolpath which I want, right? So you want to make sure right here you can see that green checkbox on your toolpath. I want to click this toolpath, hold my right mouse button, drag this down, let go, and I can then copy after. Okay, that's going to go ahead and just copy that toolpath. Now, if I create a new toolpath, it's going to insert that new toolpath right here. So I want to make sure to bring my arrow down again. Right, so this is kind of where you can change where you want a toolpath to be inserted. Right. And let's say, since it's a finish pass, I don't want to do any depth cuts. I'll change this to finish the outside. And I'll go ahead and I'll turn off my depth cuts. Oops. And that's just going to go ahead and make a simple contour, but with no depth cuts. Don't have to do that, but I usually do because it gives a little bit nicer finish. Okay. So we've got this pocket right here, the big feature on this part, and we want to obviously cut the material away. So as I've gotten more and more into Mastercam and programming, the less and less I've used what are called classic toolpaths. Those are the toolpaths like contour. Obviously contour is critical toolpath, but for example, this standard pocket method here. I'll go ahead and I'll just demonstrate what a simple pocket will look like, right? So I'll select my geometry as I would normally, right? And just quickly showing you cut parameters. There's not a lot of toolpath control that I have. There's only a limited number of styles here, and all of them tend to cut a lot slower than they're capable of. So I'm going to actually just not even show that. I rarely use a standard pocket toolpath. All right. And what I'm going to use, I do not wish to keep that. I'm going to use a newer style toolpath called Dynamic Milling. All right. So what Dynamic Milling does is it looks at this toolpath here, this contour, this feature, and it's going to make sure that when a tool is coming in here, and let's say it's coming and hits this corner right here, right? When it hits a corner, it's engaging the tool a lot. So when it just comes in and cuts like this, each time it hits a corner, you're going to overload that tool. What a dynamic toolpath does is it comes in and it sort of peels away, and it comes and peels away, and it sort of is peeling away material versus plowing through it. So let's go ahead and I'll show you the simplest type, which is kind of just a pocket. We'll use Dynamic Mill. It's right here, Dynamic Contour. Dynamic Contour is actually a finishing style. We want to do Dynamic Mill. So it's a little more involved here in terms of selecting geometry, so we want to be careful not to go too crazy. For the most part, with a simple closed pocket, all you got to do is choose your machining region. So I'll go ahead and I'll select chain here. I'll grab that. Direction for the dynamic mill as well as standard pocket toolpaths. The direction of this arrow does not matter in this case because it knows that it's going to contain itself within this boundary, and it knows that it's going to be going counterclockwise. So you don't have to worry about that direction in this instance. So okay that. And I want to do stay inside, right, because we're inside this pocket. We can do, if we're cutting an outside, feature, we can do from outside. And in a later video, I'll show you, what these other options here are used for, because they do come in use quite a bit. All right, so we, same chaining sort of process, a little more involved, and a similar interface here for the parameter screen. So you can see what I was kind of trying to show you before, that style of machining. So this is what it's going to do here. And again, it allows you to better control the tool load. And what I've found is that, with a $60 end mill or an $80 end mill, a carbide end mill, I found that I can increase the tool life on those tools quite substantially. And it also leaves a better surface finish and gives the tool, much longer tool life. So let's go and grab a tool. I'll actually change it out to, let's go for a half-inch end mill. So we'll get in a filter, grab our half-inch flat end mill. Now cut parameters is where we really get to work here. So a lot going on. Right, we're going to leave some stock on both the floor and the walls. So I want to leave, let's say, 0.01 or 0.10 of an inch on both the floor and the walls. Alright, so step over is kind of what you would expect. How much step over per spiral or cut are you going to be doing? And that number right there is a percentage of the tool's diameter. So 25% of 0.5 is 0.125. Alright, I'm going to actually lower this. We'll say 20. It's probably okay at 25, but I just want to lower it down a little bit. Alright, we're good there. I'm actually not even going to mess with depth cuts, even though it's a pretty deep cut. The reason being is that I'm going deeper with the tool and the cut, but I'm actually taking a very small radial step over. So I'm using more of the axial length of the cutting flute, and that's actually distributing the cut forces along a greater portion of that cross section of the tool, which again, good for tool life, and that allows me to cut much deeper depths. If I was cutting 1 inch deep, I might even lower this to 10% step over. So a lot of control that you can squeeze out of these tool paths that really generates great cutting action. Final thing I need to do is entry motion, right? Because we're kind of entering this, we don't just want to hammer straight into that and start cutting. So we're actually spiral helixing into it. I'm gonna, because my tool is a half-inch, I want to actually lower this just a hair, 0.2. And my linking parameters again, I want to set a depth. So we'll go ahead, set it to absolute, choose our depth. And that's going to be down here. Alright, so 1/2 inch, and we'll go ahead and click OK. So much different looking tool path here. Very different. Alright, so one thing I want to do is, I'm not sure if that tool is cutting all of this material. Right, so I want to look and come in here and measure one of these radii. So right click, analyze entity properties. Let's take a look at that. And it's a radius of only 0.195. Okay, so this tool is a 1/2 inch diameter, which means it's not actually going to fit in there to get those radii all the way cut. So we're going to have to come in and finish later with a different tool. For now, let's go ahead and we'll play our tool path and we'll take a look at it so you can see spiraling in. Let's slow her down a lot and start that over. So spirals in, getting all the way to that final depth and then doing its cut. So a lot more movement here, a lot of more cutting action. So right here, that when it's actually coming off of the wall, on these back cuts. Those are called back feed motions, and it's actually the tool lifts up a very small amount and rushes back. So let's go back into our toolpath parameters and take a look at that in the cut parameters screen. Alright, micro lift distance here. So it's actually picking up 0.01 and going back feed rate at 100 inches per minute. Let's crank that up to 400. I have that typically set as a default in my machining, so that just tends to decrease the length that the toolpath is going to be cutting. So again, let's go ahead and grab everything. So we've got all of it by selecting toolpath group here and simulate it. And go ahead and play. So we're going really fast. Let's slow it down a bit. Start over here. And now we can really see what's happening with our toolpath. So as you can see, it's kind of peeling away that material versus plowing through. So we've got some of that pocket cut away, but not all of it. So let's go back in here. You can leave that open. Take a look. So what I want to do is called rest machining. What that means is it's going to come in and it's going to pick up whatever is left behind. So what I'm going to go ahead and do is I'm actually going to right click, hold that right click, copy that, oopsies, go ahead and copy that toolpath after. Move that arrow down again. We'll go and we'll figure out what's going on here. Okay, so I know that that radius is or the diameter of that corner there is 0.39. So let's go ahead and use a 3/8 end mill, flat end mill, to come in and finish the walls of that. So let's go ahead with the 3/8, and we'll go with our stock here, and we can actually click rest material. So it's going to use the rest material from all the previous operations, or I can use one other operation or from the roughing tool that it was using. We'll go ahead and leave it all previous operations. We'll go into our entry motion, and because we've already cut a lot of that away, we've already got a pocket there, we can actually go and do plunge only. So it's just going to go straight down in there. Linking parameters should be already set. Let's take a look at our overlap here, and we can actually increase that to like 60%. And we don't want to leave any material on the walls, or on the floor, sorry. Let's leave 0.005 on the walls, and we'll come in with a finishing contour pass. So let's take a look at that toolpath. Alright. We'll kind of back plot through it. I'm going to step through here and see what we've got going on. So it's finishing my floor, just spiraling out. Now it's getting into those corners there. So we're going to we increase that step over for two reasons. Really, to get a nice finish on the floor, and also to not take forever cutting, because we are really just skim cutting 10,000ths off the floor, and so we want to kind of speed that process up. So got the floor is finished. We've cleared away those roughed out walls there. Let's go ahead and take a look again at what our simulation looks like. Play through. See here, speed it up a bit. Okay, so we've got that pocket fully machined, roughed out, but you'll see you've kind of got these little breaks here, these vertical striations. So what we need to do is come in with a regular contour toolpath. Dismiss. Come in with a regular contour toolpath, and we'll finish that up. So I'm going to go through this really quickly since we've already done a contour. First thing I want to do is save this again. So that would suck if I lost all that work, which I've done quite a bit. So just to quickly go through this, I'm going to chain this fast and run it kind of the speed that I would program something. Simple. Alright, so I've got a finish pass, but notice right there that my lead in, my lead out isn't really doing anything, and I don't want that, right? Because it's starting in this corner, the software is not smart enough to know what to do. So if I click my geometry here, I can open up that chain and right click and choose start point. Now it says forward or back B, so let's go F. We'll start it let's start it right here and enter. And then we'll go ahead and regenerate that toolpath. Nope, too far. What I can do is I can either back it up and we'll see what that does. See if that fixes it. There we go. And another thing I can do in lead in and lead out is turn off enter and exit midpoint enclosed contours. And you'll see kind of ends right there. So we want to leave that engaged for now. But there's my finished contour. So that whole pocket right there is already done and we're good to go. Now if I had roughed that pocket with a 3/8 end mill, I probably wouldn't need to do that extra toolpath, but I wanted to show you how to do rest machining so you can get all your material taken out quickly and efficiently. Now I'll show you a really quick pro tip before we pause this video and move on. So if I go into File, Configuration, and I go to Start Exit, I believe. It's hard to find this stuff sometimes. Here we go. Autosave backup right under Files there. I want to turn on autosave. I want it to autosave every 15 minutes. And that way if it does crash or I lose my work, I'm only losing 15 minutes at a time. And I want it to prompt me before I save because maybe I don't want to save. Maybe I'm still working on something that I'm not sure about. So I'll go ahead and click OK there. And that's going to prompt me to autosave every 15 minutes. So we'll go ahead and we'll pause here, come back, and we'll finish up this part.